Okay, so question number 1 to 13 completed by Sahitya. So this one is from the vector calculus now. So which are the most important articles? First, I will tell you. So if you observe, there are two parts in vector calculus. One is vector differentiation and the second is vector integration. In vector differentiation, we have gradient, divergence, and curl. So these are the most important three articles. Then we have other articles like velocity, acceleration, and tangent vector. Velocity, acceleration, and tangent vector. So these are the three important. So there are few articles like torsion and curvature that is not part of our syllabus. So you should not worry. Then if you come to the vector integration, in vector integration we have three theorems and one line integral, that is line integral or work done, and three theorems, namely like Green's theorem, Stokes theorem, and the Gauss theorem. So you should know the formulas of each theorem or the statement of each theorem, I will say, and definitions of these curl, divergence, and gradient. So let me start here. So question 1 is just we have to find out the unit tangent vector for the particle which is moving on this parametric curve. So always we know that r bar is a position vector and that is given as xi plus yz plus zk. Remember, throughout you have to keep the same notation. So either use a cap notation throughout or without cap you can write it. So this is the position vector r bar. So once we have that position vector, that is known as the rate of displacement or rate of displacement vector. So if you take that first derivative dr bar by dt, why second order derivative is written, Sahitya? Hmm?
It
Tangent.
is first order only, by mistake.
Okay, by mistake you written second order. Okay, so this is not only notation is not correct. Actually, velocity vector v bar is a dr bar by dt. Dr bar by dt. So that's a derivative. And if you observe, which is the dx by dt, that is 1 I cap, dy by dt j cap. So that is 2t j cap. So first you should write a general. So not written. This is also here is not 2t is not written. So you will observe just I cap first because dx by dt is 1, dy by dt is a 2t. So it is a 2t j cap and last 3t square k cap. So this one is the general velocity vector. This is the velocity vector at any instant t. Okay, and we want that velocity at a particular instant. So just replace t by 1. So the answer will be I cap plus 2j cap plus 3k cap. So the final answer he is written correct. So this is the correct answer, but in between a small correction is there. So suppose this question is for t equal to 2, then that time he may get a wrong answer there because a small, okay, this is just a simple differentiation. And one most important thing, remember, in calculus, this vector calculus, you have to differentiate. I will tell you. You will find it's very simple that 11th standard student can do it. So just you require derivatives of simple function like derivative of x raised to n. Okay, derivative of x raised to n. We want a derivative of e raised to ax. We want a derivative of sin x and cos x. Sin x and cos x, and lastly the product rule. So these simple difference and maximum quotient rule. So these are very simple. Maximum 4, 5, 6 formulas are there of differentiation that we require. So don't think now it is a calculus and calculus is a very difficult. Just you focus on basic formulas. You can do these questions, but provided you know these concepts that if r bar is a position vector, dr bar by dt is a tangent vector or a velocity vector. Both are same. That's what. I hope there is no there should not be any doubt in the question 1. If anyone have, what is the question? Question is okay, calculated velocity vector, then unit velocity vector or unit tangent vector. So unit tangent vector is v bar upon mod v bar. That's correct. And just divided by the magnitude of a vector. And how to get a magnitude? Square root of 1 plus 4 plus 9. And that is the root 14. So this is the correct answer. Good. Okay. So if anyone have a doubt, yes, you can ask in between also. Come to the question 2. Equation of a normal to the surface Now quickly, which thing comes in your mind when the normal word appears? Normal to the surface mainly. Yes. This is the keyword. This is the keyword which indicates gradient. Correct, Rishan. So already I told there are three keywords: normal to the surface, directional derivative, and gradient. Correct. Okay. So directional derivative, gradient, and normal to the surface. So if these three keywords are coming, definitely you have to calculate gradient only. That is a del phi. Okay. So that about the first identification. Now we want gradient. So surface f is a given. Just del f. If we calculate del f is a dou f by dou x I cap plus dou f by dou y j cap plus dou f by dou z k cap. So this is the general, this is the definition we can say, and this is the gradient at any point x y z. Just dou f by dou x is written 4x plus dou f by dou y is a 2y j cap and dou f by dou z is a 2k cap. So yes, all these things he written correctly here. So that about the general gradient, but we want that gradient at a particular point 2 1 minus 3. So we have to just replace the values of xyz. So if we replace these values of xyz there, like 2 1 minus 3, we get this as answer. So 8 2, yes, correct, and minus, so plus 2k only. See, this term, this gradient is actually independent of z. Z term is not appeared anywhere. So even though z is minus 3 or it is minus 10, it doesn't matter. The grad f remains, this k component remains same there. Equation of a normal to surface is, so yes, this is the equation of a normal vector to the surface, but that's the final answer only. But this is the equation. This is the equation in a vector form, or this is just a vector. Sorry, this is a vector which is normal to the surface, but we want the equation of that straight line. Equation of straight line. So we use point, passing point and direction ratios form. So if you observe this 8, 2 and 2 are the direction ratios. Yes, dr written direction ratios of that straight line, and the straight line is a passing through 2 1 minus 3. So this is the equation of a straight line which is a normal to that surface at this point. Okay, at this point. So that about the answer. So general form is like this one: x minus x1 equal to y minus y1 equal to z minus z1. This is x1, y1, z1 is a passing point, and this ABC are the direction ratios. Okay, direction ratios there. So that's about the equation of a straight line passing through the point x1, y1, z1, having the direction ratios, the ABC is there. That's all. So answer is correct. That's good. So I'll come to the question 3 now. So let me just see the question. If u is a u of xy, v is a v of xy, then the area element du dv is related to the area element dx dy by a relation. Actually, this we discussed in multiple integral in last semester only. Yes, anyone knows other than Sahitya? If right now we want small area du dv which map to the small area dx dy, how it is mapped? It is mapped with the Jacobian that we see in the transformation there. So du dv is a Jacobian of uv with xy into dx dy. Okay, what is written? H1 H2? Yes, yes, Sahitya. Why it is H1 H2? This is actually the last semester we learned. Suppose we have small area in a UV plane. So this is a UV plane, and we have small area. Say it is a du dv. This is the du dv, and there is a another plane, say xy plane. XY plane. So this small area is mapped with this transformation. There is a transformation, and if we want the value of a du dv in terms of this say dx dy. So du dv is the Jacobian of uv with xy into dx dy. So that's the formula. This is the formula. Is it clear? Any doubt? This is Jacobian formula. If we are given these values of that function u and v, then we can calculate that Jacobian. That Jacobian is a determinant of dou u by dou x, dou u by dou y, dou v by dou x, and dou v by dou y. It's a 2 by 2 determinant. Any doubt there? Is there any doubt? So this should be the answer. This should be the answer. Yes, anyone? Any doubt there? No. Okay, good. So that about question 3. Question number 4. In between, Raunak is asking, so college is calling students. They have called PVD and second year NS student on 14th. When they are calling us, obviously the priority will be first, third year, then second year, then first year. Because okay, yes, you will also be called. Don't worry. I think half of the batch already called, na? So one of the division last or only first year ME for division. Okay, we'll not discuss that thing right now. Okay, we'll see that later on. Yes, college is calling. That's correct. Because mm, IMU also given some permission for IMU and DG shipping. Plus, government is also giving the permission to allow the student. If a government allows more than 30% or that time, yes, college will definitely call you, because college is interested to finish your practicals also within a time, so that no one will wait, because if you are not finishing your practical, you will not be uh, you will not start your selling. So because of that, obviously in the required order they will call you. Okay, so out of box question. Okay, question number 4. If a is a 2x square I cap plus this one is a is a given, so whether a is a scalar or vector quantity? Yes, anyone? Whether a is a scalar or vector quantity? I am asking. Okay, yes, Neil, correct. It is vector quantity. Why now? Why this in the textbook? Yes, correct, Neil Asif. This one is vector quantity. Because in textbook, remember the capital letters, bold letters are used for denoting the vector, and unbold letters are used for the scalar. So bold A, in bold it is written A. So sometimes that it is a restriction of a typewriter that times. So because of that, they are using that notation. But in an exam, don't follow this notation. Whenever there is vector, just put a bar on that. A bar, you can write it. Okay. Okay. So Parth is saying he have the network issue. So mark me a present. No issue. Okay. So we have to calculate a gradient of. Is it a gradient now? Del A. It is a del of A bar. It is not del A. It is a del of A bar. So del dot A bar is known as, it is a divergence. Okay. Correct. Yes, correct, Neil. It is a divergence. So dou f1 by dou x plus dou f2 by dou y plus dou f3 by dou z. Okay, good. Just you write down the derivative. Dou f1 by dou x is 4x, dou f2 by dou y is minus 3z, and dou f3 by dou z is a 2xz. So all derivatives written correct. Only I will tell you one important thing. If possible, try to use a correct notation. This chronicle delta is used for the error notation. Actually, this used for error function, or there are other notations also. This when we say dou f by dou x, it is this notation you can use. Okay, so use correct notations, not an issue, but answers are correct. So even though with this notation you finish in the exam, you will get a marks. Don't worry, because generally in IMU exam, when we correct, no one is so strict there. Everyone gives the marks, provided your concepts are clear. Okay, your concepts are clear there. If you written wrong answers at the end, you will not get a marks there. So this is just this is the divergence, and divergence is a scalar quantity. You will observe it is free from ijk. It's free from ijk. Don't write ijk in the divergence. So this is a silly mistake. Many of the students do it, and don't forget to write. Don't forget to write ijk in a gradient. Gradient is vector quantity, so you should have that ijk there. Question 5. Divergence of curl f is a 0. So what about that question? Yes, divergence of curl f is 0 and f is given, is it? Or okay, divergence of curl, what is the answer that you have tried it? This is fill in the blanks. Okay, so you've taken f bar as xi plus yz plus zk. So mathematically, the question is divergence of curl means the question is asked del dot del cross f bar, na? Del dot del cross f bar, and yes, the answer is 0, correct. You can take a simple logic. If you see, this is a determinant, this is a dot b cross c. What is a dot b cross c? Yes, anyone? A dot b cross c, this is the box product, is it? That's a box product. So what happens, the first one is the operator dou by dou x, dou by dou y, and dou by dou z. Second del is also the operator, so this is a dou by dou x, dou by dou y, dou by dou z. And third is f1, f2, f3, f1, f2, f3. Now if you expand this determinant, yes, your answer will come 0, because two rows of the determinant are identical. Two rows of the determinant are identical, and when divergence of curl f means del dot del cross f, this is the box product. Box product is given in determinant. Two rows of determinant identical, so value is a 0 there. So here in particular shown, but in general you can write like this also. Okay. So fifth is that one. Sixth, area bounded by the simple closed curve C is given by okay, so it is written 1 by 2 x dy minus y dx, correct. So this is 1 by 2 line integral of x dy minus y dx. This is one more formula that we can use it to find the area bounded by the closed curve. Closed curve is there. So previous formula that you learned in last semester is double integral dx dy. Double integral dx dy. So with the help of Green's theorem, you can prove this formula. Okay, we can prove this formula, but we will not go in the proof. Just you can remember this 1 by 2 integral x dy minus y dx over c there. Any doubt there, or you want the proof here? I don't know up to which difficulty level the questions will come in exam. Still, actually, the exam date is also not declared, so don't know what is going to happen. Okay, so that about the question 6. If you have the doubt, yes, you can ask. Question number 7 now. If S is a closed surface enclosing the volume V and R bar is this one, then this is now tell me whether it is a single integral or double integral. What is the meaning of this? Is it a single integral or double integral? Yes, anyone? Is it a line integral or surface integral? I'll change my question. Yes, Asif is saying it is a surface is there, so double. Yeah, correct. Good. Very good. So even though single integral shown, it is a double integral because ds is written on the surface s is written. So indirectly the question is, what is a double integral? R bar, this is a position vector R bar, you can use R bar. And nds is actually n cap ds. N is a normal vector. So R bar dot n cap ds over the surface, yes. So both are same. So some authors are using this notation, like B.S. Grewal. B.S. Grewal, you have this notation. But other way, this question can be asked this format also. And now, S is a surface. This is a closed surface. So can you tell me how to do it? Why 3v is the answer written? Yes, by which theorem? Which theorem? Which theorem converts double integral to? Yes, anyone? Not Green, Asif. Yes, Asif, that's true that Green's theorem and Stokes theorem convert double integral to the line. But here we have the Gauss theorem. Sahitya said correctly. So it's a triple integral del dot f bar dv. Okay. Just 1 minute. Just 1 minute. I have call. पप्पा अर्ध्या तासाने फोन करू का लेक्चर चालू आहे नाही 3:30 करतो 3:15 3:30 ओके ठीक ठीक ओके okay so where we are here so this is the Gauss this is the Gauss theorem. Yeah, it is a Gauss theorem. Double integral of f bar dot n cap ds is equal to triple integral del dot f bar dv. So f bar is in this case r bar. So it is del dot r bar dv. In this case, it is a del dot r bar dv. Now, if you know del dot r bar, that del dot r bar is 3. So triple integral 3 dv, and now 3 is a constant outside. Triple integral of dv is a volume v. So 3 times v is the answer. That's correct. Okay, good. So Gauss theorem we used. Remember, whenever closed surface is there, this is the keyword. This is the keyword. Closed surface means you convert double integral to the triple integral. And when it is open surface, yes, when it is an open surface, then we convert double integral to the line integral. Is it clear? Is that clear? See, when we use the Stokes theorem, Stokes or Green, whenever the surface, Green's theorem is obviously for the plane surface. The surface should be an xy plane. Okay, that is a Green's theorem. Now, when we use the Stokes theorem, for Stokes theorem, the surface should be open. Open means like this. This is the surface, yes, which is open from the bottom. And that surface have the boundary as the curve C there. So that about Stokes theorem. Stokes theorem. But here we have closed surface. The word closed surface is used. So surface is like a complete sphere. Okay, the surface is like sphere. And in such a case, surface integral is converted to the volume only. Okay, volume only. So that way we decided that theorem. Question number 8. We say divergence of r bar, and that is 3. So this is a very simple proof, and that only we used here. Del dot r bar is 3. Good. So this is the standard results. Which are the standard result? Divergence of r bar, then gradient of r, okay, or curl of r bar. So all these are standard result, and you should know. So here both the result here side the written. Divergence of r bar is 3 because del dot r bar is 3, and curl of r bar is a 0. Curl of r bar is 0. So r bar is a irrotational field. Okay, the position vector is itself a irrotational field. Come to the question 9. If a is such that del cross a is a 0, then a is called irrotational vector. Good. You have to, if it is a multiple choice question, you have to just see the correct option whether irrotational is written or conservative is written. So both conservative and irrotational vector are the del cross a bar is a 0 there. Any doubt up to here? No. So question number 10. Del dot f is given as a 3. So surface integral of fn dot ds, where s is the surface of a unit sphere is. Yes, can you see a small difference? This is the same question actually. We are given s is the surface of a unit sphere. So unit sphere is a closed or open surface. Is it closed or open? Yes, unit sphere is a closed surface or open surface. Is the unit sphere is a closed surface or open surface? Am I audible?
Yes, sir.
Okay. So why I'm not getting the answer? Unit sphere, close or open? Sphere close होता है या open surface होता है? Close. So why that much of time?
Close,
Just
sir.
good actually. Okay, Akshay, thank you. So it is closed surface, and when it is a closed surface, the question is from surface to the volume. So we have to convert this one double integral f bar dot n cap ds over the surfaces. So this n ds is actually n cap dot ds. Okay. So n is a normal vector to the surface, because probably that n is written in bold letter in the book. So double integral f bar dot n cap ds is equal to triple integral of del dot f bar dv. And now this triple integral del dot f bar is already given, that's 3. So this is a 3 dv. So answer is a 3 into volume of the unit sphere. What is the volume of unit sphere? What is the volume of the sphere first? 4 by 3 pi r cube, is it? Out of that, as it is unit sphere, that r cube is 1, this is 1, r is 1, so 3 gets cancelled and 4 pi is the answer there. Is it clear? Any doubt? Is that clear? No doubts. Okay, 4 pi is the correct answer. Now question number 11. If del dot f is a 0, then f is said to be solenoidal vector field. Correct. Solenoidal vector field. That's correct answer. So again, Saitya is following the BS Grewal notations only. This capital F is written in the book bold form, but you cannot show the bold form here. So try to write a bar notation. Del dot f bar is a 0, then f bar is a solenoidal, because otherwise we cannot distinguish between vector and scalar what you are writing. Okay. Question 12. The directional derivative of a phi at a point 1 minus 2 minus 1 in the direction of a PQ is. So this is one of the example actually. This is a little lengthy calculation how to do it. We want a directional derivative. So the keyword appeared again. So directional derivative indicates a gradient only. We have to calculate del phi first, which is this formula dou f by dou xi plus dou f by dou yz plus dou f by dou zk, and it is x square yz plus 4xz square. So dou f by dou x is 2xz plus 4z square I cap plus dou f by dou y is x square z j cap, and this dou f by dou z x square y plus 8xz k cap. That's correct. So this is the general gradient. This is general directional derivative. This is the directional derivative at any point x, y, z. We want that directional derivative at the point minus 1, 2, 3. So here the point is given at minus 1 minus 2 minus 1. Sorry, at this point we want it 1 minus 2 minus 1. And so just replace and we got this vector. So this is the vector at that, this is actually the directional derivative at this point. Directional derivative at the point 1 minus 2 minus 1. But we want this directional derivative along the line PQ. So PQ bar is calculated. PQ bar is Q bar minus P bar, and that's correct. This is the way you can find out. Q bar minus P bar. We are given position vector of Q and P. And lastly, del phi dot PQ bar upon magnitude of PQ bar, and that's the required answer. So good, that's the correct answer. If anyone have a doubt here, yes, you can ask. Yes, this is one of the lengthy question actually. So for 1 mark, yes, it is not justifiable, means we cannot justify it for 1 mark there. So it should come partially it can be asked, but we don't know about which type of the questions will come there. Okay. Question 13. Last, u is equal to x square yz, v is xy minus 3z square, then del dot del u cross del v is equal to 0. Yes, okay, so this is just same thing. It is a gradient. Yes, Sahitya, this you already written now. You written one statement before this also. One of the question you written there. What you written? This is a divergence. Sorry, divergence of curl f bar. Okay, curl f bar is a 0. So this is sorry, it is a divergence of curl f bar is a 0. So that is one thing. It is similar to that. Actually, del dot del u cross del v is there. Okay. So one way, yes, you can write in the box product form also. You can write in the determinant form. Okay, there are multiple ways to complete it. One of the way, yes, this LHS, this can be written as a determinant. First row, dou by dou x, dou by dou y, and dou by dou z. These are the components of del operator. This is del operator only. Now, components of del u will be dou u by dou x, dou u by dou y, and dou u by dou z. And then components of del v, which will be dou v by dou x, dou v by dou y, and dou v by dou z. And now you can expand this determinant. You should get the answer maybe the 0 there. So this is one of the way. This is yz and zy. Obviously you can see what you are going to get it. Dou u by dou y, dou v by dou z. Okay, this way you are going to get it. No, but you have to then apply x also there. It become lengthy. So by this way, yes, it will become lengthy by determinant way. So if you know, yes, it is a box product only. Del dot del u cross del v there. A dot b cross c. Is there any other way? Yes, anyone? This is one of the way. Just you have to expand this complete determinant and you have to check few terms. I think the terms will get cancel each other. You have to expand it, but you have to take that effort there. Is it okay? Yes, any doubt? Okay, clear, good. Thank you, Saito. So that about the first 13 question. We'll finish one more set and remaining we'll take it tomorrow. Okay, so right now I will take one more here. Uh, 1 to 13 we finished, 14 to 24 now. Okay, so these questions completed by Neil. Question number 14, curl of it is just like xy I cap plus yz j cap plus x zx k cap. So we have to find out curl. So it is a del cross f bar. Yes, correct. And F1. So to detail you written. Don't do this detailing in the MCQs question. Directly you can put F1, F2, F3 here, and you have to take I cap into this derivative with y, this derivative with z, that is written y. Okay, so I think it is correct. It is just a formula oriented question. If anyone have doubt here also, you can ask. The correct answer there. Any doubt? Next question, f bar is given, f1, f2, f3, del dot f. We have to calculate del dot f. So this formula you have to write down, divergence f bar. So don't write it Ijk is there. That's correct. So it is a this is the formula for just divergence of f bar. Divergence of f bar. Question 6. Yes, Rishang also have the connectivity issue. So he may also disconnect. No issue. If f bar is the conservative vector field, then what is the curl f? If it is a conservative, yes, del cross f bar is a 0. If it is irrotational or conservative, curl is a 0 there. Good. Just a property. 17. 5 this one, then we have to find out gradient at this point. So it is a formula oriented again. Just have to calculate gradient means del phi first, which is the general gradient at any point xyz. We want that gradient at this point, so we get this as a vector there. Good. This is the answer. So this is again straightforward. I think there should not be a doubt in 17th. 18th. Curl of r bar. This curl of r bar, and that should be 0. Already completed. I think this is already asked actually. So, next 19th. Work done. We want work done formed by on the square of the lines y equal to plus or minus 1 of the force. This one. Now, if you have to find out work done, for the answer he got, I will check it. Yes, he got is 0. Now, too much calculation he done. One thing also you can do it whenever the one of the option available is a 0. Just you have to check whether this f bar is a irrotational field. If it is irrotational or conservative field, work done over a closed path is a 0. And right now the path we are given is a square. The path we are given a square, so we have to find out the work done, which y equal to plus or minus 1. So these are the boundaries we are given: x plus or minus 1, y plus or minus 1, and z is a 0. Obviously the square is an xy plane. So dz, z is a 0, dz is a 0. There is no need to write the term of f3. So this is 0 at the end. So that's written correctly. So now, what he done? He completed this work done on path 1, path 2, path 3, and path 4. So, if it is coming, see, x is 1, y is 1. So, no need, sorry, that is also not required. Good. If x is plus or minus 1, dx is a 0, dx is 0. And if y is plus or minus 1, dy is also 0. So, if dx, dy, dz are 0, this dx is 0, dy is 0, dz is 0. So, work done is a 0. Work done is a 0. That's correct. Okay, so simple. So simple. So whenever the boundaries are constant and it is a closed path, remember the work done is a 0 there, obviously. I hope it's clear. Or you can check the conservative, is that vector field conservative, that way also you can go. 20th, curl of grad phi, del cross del phi. The question is find del cross del phi. Okay, del cross del phi is a 0, you observed, del cross of del phi, and that is coming as a 0 vector. This is a 0 vector, correct? Good. Just step by step calculation is completed, Neil. Good. Question 21. If A is a constant vector, then divergence of A bar cross R bar. A bar is a constant vector, so A bar is a constant vector, R bar is position vector. So divergence of A bar cross R bar, the way he proceeded, okay, he done with step-by-step calculation. First he calculated A bar cross R bar. So A bar is say Pi plus Pj plus Pk. Neil, remember, not necessarily all the components are same. Okay, whenever you have the constant vector, you should not take like this. You take constant vector as ai cap plus bj cap plus cz ck cap, sorry, ck cap. Is it clear? So not necessarily all the components will be only same p. So it can be abc, or it can be p1, p2, p3 also. And then you have to calculate this cross product of uh, ijk, ABC, and XYZ. So this way you have to find out. I hope you are getting what I am saying. So this is not correct actually. So because you cannot take P only, then you have to expand this. You will get first A bar cross R bar, A bar cross R bar vector, and then we can take divergence of that. So it is A bar cross R bar. Let me finish it. So I cap as it is. This is BZ minus CY, BZ minus CY minus J cap, AZ minus CX, and plus K cap, AY minus BX, AY minus BX. And now the lastly we have to calculate the divergence of this, say you can denote it by F bar also. So divergence of F bar. Now do f1 by do x, derivative of f1 with x. You will observe f1 is free from x, so it's a 0. Do f2 by do y and do f3 by do z, and that's a 0. And the correct answer is correct here, but the way approach, little correction. I hope there should not be a doubt here. So the answer is 0 only. That's good. Only there is correction, instead of p, you can take a, b, c there. Question 22. If r bar is position vector, then gradient of log r and gradient of r raised to n. Okay, not completed, but I will tell you one of the formula that you can remember this formula. Gradient of function of r, gradient of a function of r, yes, I will share it. Gradient of function of r is f dash r into r bar upon r. So this is the shortcut formula to get a gradient for the some function of r. What is the r actually? R is root of x square plus y square plus z square. R is the magnitude of the vector, position vector, and r bar is xi plus yj plus zk. So if r bar is xi plus yj plus zk and r is this one, so gradient of f of r is f dash r into r bar upon r. Now can you tell me the gradient of log r? So what will be the del log r then? What should be the del of log r? What is f dash r first? What is the derivative of log r with respect to r only? 1 by r into r bar upon r. So answer is r bar upon r square. Del log r bar upon r square is the answer for the first. And what is a del of r raised to n? N r raised to n minus 1, that is f dash r into r bar upon r. Now if you take these r combined, this is n r raised to n minus 2 into r bar. So that will be the answer. This will be the answer and this will be the answer. Any doubt? Is there a doubt? No doubt? Yes, many of the students' networks is going down now. This is third or fourth student who is saying the network is low or down. I can disconnect at any time. Okay, so they are like threatening me now. Huh? Yeah, so no issue. Okay, the level surface is f of xyz equal to 0 or f of xyz equal to constant, I think. Anyone have the idea about this level surface? F of xyz equal to not only 0, f of xyz equal to constant, that can be the level surface. Because what is a level surface? I think a little bit out of box, but you can just Google for this and you can find it. Level surface. It may be if we change the value of a constant, we get a different level surface like this. Like if we have, let I show you. Suppose you have x square plus y square plus z square is equal to say c square. If you change the value of c, suppose c is a 0, you get just a point, but if c is a 1, you get a sphere of radius 1. If c is 2, you get a sphere of radius 2. C equal to 3 sphere of. So you are getting the level surface, like first point, then another sphere, then outer sphere, then outer sphere, and out. So you are going to get a level surface. Okay, these are the level surfaces. So at different levels, you are getting to get different, so parallel to each other. So that way. So because of that, I think the level surface is this one, f of xyz, sorry, xyz equal to constant. F of xyz equal to constant is a level surface there. So that is the level surface, not only 0. 24th, unit normal vector to the surface z at this point. So we already discussed this type of a question. We want unit normal vector to this surface, but surface is not given in standard form. What is the standard form? We are given f of xyz equal to 0 or phi of xyz equal to constant. So take all variable on one side, say phi equal to z minus 2xy equal to 0. So this is the surface equation. We want a normal vector to this surface, so which we calculate del phi first, and then we calculate del phi at that point. We get answer. Okay, we get answer. So z minus 2xy or 2xy minus z, both are correct. So here he taken 2xy minus z. So that is okay. So both way it is correct. So first del phi or del f is calculated, and then at particular point. And so divided by its magnitude. This is the answer. So that about the unit vector to that surface. That's one. Okay. So if anyone have any